All right, gang. So we've been talking about area. We've talked about areas of triangles, parallelograms, trapezoids, kites, and circles so far. Now let's talk about another situation with area. Working off of circles, all circles have a relationship. It is that all circles are similar. And there's a relationship between similar polygons and their areas. So if we want to talk about areas of, and I said similar polygons, but I meant to say similar figures. If we want to talk about areas of similar figures, there is a specific relationship between them, and a special relationship. Now let's say we had two triangles, and the two triangles were similar. Two similar triangles. Well, if these triangles are similar, then their sides are in proportion. So if I call that base 1 and that base 2, the corresponding height would be here, and the corresponding height would be here. So the area of triangle 1 will be 1/2 base 1, height 1, and the area of triangle 2 will be 1/2 base 2, height 2. Now, since these are similar, since these two are similar, we know that their lengths are in proportion. So that means that B1 and B2 are proportional to H1 and H2. And the ratio between these is our scale factor. So that's our scale factor of the two figures. Well, that's the ratio of the sides. Let's take our two areas and put them in a ratio. So if we take the ratio of the area, so area of triangle 1 to area of triangle 2, it's 1/2 base 1 H1 over 1/2 base 2 H2. Hey, the 1/2s divide off because they're the same. And this is just multiplication, so we could break this up. B1 over B2 times H1 over H2. Wait a minute, we just established that these are the same, that they're each the scale factor. So it's the scale factor times the scale factor. So the ratio of two areas of similar polygons is equal to the scale factor squared. And that's going to be true regardless which formulas you use. It doesn't matter whether it's triangles, it doesn't matter whether it's circles. So if you have two circles of radius 1 and radius 2, so area of circle 1, area of circle 2, it'd be pi r1 squared over pi r2 squared. Those pi's would divide off. Any constant in your area formula would divide off, leaving us with r1 over r2 all squared. That's just your scale factor. So again, it's scale factor squared. If you had trapezoids, so if you had area of trapezoid 1 over area of trapezoid 2, 1/2 times B1 plus B2 we'll say B11 B21 over H1, 1/2 B12 B22 over h2. The 1/2 will divide off. The constant will always divide off. And that's b1 plus b2. b1 plus b2 1 over b2 1 other way around. Now I'm just confusing myself. b1 2 plus b2 2 times h1 over h2. That's our scale factor. And if we think back to proportions, if b11 over b12 is equal to something, and b21 over b22 is equal to that same thing, then the sum of them is equal to that. That was our sum of proportions property. So this is our scale factor as well. So it's scale factor times scale factor. It's scale factor squared. So anytime you have two similar figures, their areas are the square of the scale factors. All right, hope that makes sense. That's all there is to it with similar figures. Have fun.